Hello, and welcome to this first interactive session of the course Vibrations of Structures. I hope you are all doing fine and going through this course without any problems. I hope you are also using the forum to let us know your problems. Now, I will just go through some of the things which we have covered. This is roughly, we have covered 3 weeks, and we are into the 4th week. Let us look briefly at what we have covered. In the first week, you had this introduction to the transverse vibration of strings in 2 parts, wherein not only fixed strings, but also fixed, free, and hanging chains were discussed. Then in the 3rd lecture, we had this axial and torsional vibrations of bars. In the 2nd week, we had the variational formulation for deriving the equations of motion. So in the first week, we were using Newton's second law to derive the equations of motion of the various systems that we have discussed. In the 2nd week, we have discussed this variational formulation, and I hope you have learned that nicely, because this is a very powerful method. And as we will proceed, you will find that this variational method actually leads to approximate methods. Many approximate methods have been based on this variational methods. And you will also see that these variational methods also give us the boundary conditions, the correct boundary conditions. So this method is a very complete and very interesting method, which gives us not only the equation of motion, but also the boundary conditions. We had the variational formulation in 2 lectures. Then we moved on to modal analysis of one-dimensional continua. This had 2 lectures. We had discussed some important concepts of orthogonality, of self-adjointness of the operators, and how it is related to orthogonality of the eigenmodes. So we found out the natural frequencies and modes of vibration of strings and bars. So that was in week 2. In week 3, we had this, we studied the properties of the eigenvalue problem, self-adjointness and orthogonality, etc. Then we discussed approximate methods of modal analysis. There are two lectures on approximate methods. And here, I hope you have learned this Rayleigh method and Rayleigh-Ritz kind of expansion method. These are very, very powerful and useful when you have a very complex system. So in the variational approach, we start with the energy, as you know, and we have some notion of how the system will oscillate, or what kind of vibration it will show up, and we have to do an expansion in terms of such functions which satisfy only the essential boundary conditions, which is not very difficult to find. And then you plug into these energy terms, and thereafter you complete the integration. And then you have these discrete equations of motion, which are quite easy to solve. So it's simple eigenvalue. Then it becomes a coupled oscillator problem, essentially. These are the things that we have discussed up to week 3. Week 4 will discuss the initial value problem, which you know from a basic vibration course also, how initial value problems are solved. Then we will move to the forced vibration analysis of one-dimensional systems. Okay. So if you have any questions, comments, queries, you can write it in the chat box of the YouTube channel. And so in particular, I would like to know how is the level of assignments and the lectures, the lecture videos, whether you are facing any difficulties in understanding or in getting these videos, or in these assignments, what kind of difficulties you are possibly facing. That is what we would like to know very much from you. So please feel free to write in the chat box. So you're welcome to give your comments, your observations, your difficulties, doubts here in the chat box. I've received one question from a student. Okay. Mr. Jagannath Prasad, you have mentioned about free vibration of, I think, rotating Timoshenko beam. You have asked about free vibration of rotating Timoshenko beam, which actually we will not cover. We have not yet reached analysis of beams. When we come to that, we do have Timoshenko beams, analysis of Timoshenko beams, but we have not discussed rotating Timoshenko beams. But you can easily extend, when we discuss this, maybe in the live session, in the second live session, maybe we can take this up. Then there is a question on non-dimensionalization of design parameters. This question is by Mr. Vijay. So Dr. Vijay is a faculty, and He's asking about non-dimensionalization of design parameters. Essentially, for example, so when we do analysis of dynamic analysis, it is sometimes a very good idea to non-dimensionalize the equation of motion. So the way we non-dimensionalize is we take, for example, the field variable. Field variable is displacement. We non-dimensionalize displacement, the displacement field variable, using the length of or the length scale of the problem. For example, in case of a string or in case of a beam or a bar, we will define a non-dimensional field variable, which will be, let's say the field variable, dimensional field variable is w, x comma t. Then we will divide it by the length of the beam or the string and define a new variable, which will be a non-dimensional field variable. Similarly, so this is the field variable, the dependent variable. The independent variable, which is x and t, they are non-dimensionalized. Again, x is non-dimensionalized by the length scale of the problem. That means the length of the string, etc. Time is non-dimensionalized by the fundamental frequency, for example. If you do this non-dimensionalization, finally the whole equation of motion becomes non-dimensional. Then it is very easy to see which non-dimensional parameters controls the dynamics of the system, in what way. This we will discuss actually under beams, under tension beams. So that is for non-dimensionalization. So please write about your problem on the chat box, YouTube chat box. I hope you have the link to the YouTube channel, which is currently live streaming. So I would be interested in knowing about how well are these lectures working for you in terms of understanding, in terms of solving the assignment sheets, etc. So please write now in the chat box. There is another point that has come up in the Excel sheet. Mr. Ganesh, who is a student, he has only written vibrations. Now, from here it is a little difficult to make out what the question is. So I hope you have been able to follow the lectures. For example, in understanding boundary conditions, strings can be fixed strings. In that case, for example, the displacement at the ends, that becomes zero. Whereas if it's free at a boundary or a sliding boundary condition, then there is no transverse force. Therefore, the slope of the string has to be zero. That means del W del X at that end. And all the derivations of these things have been discussed, and I believe that we have been able to follow up with this. So because understanding these boundary conditions and their nature and whether they are essential boundary conditions, what are known as also known as geometric boundary conditions, or they are dynamic boundary conditions, is very important. This will become particularly important when we discuss approximate methods. For example, in Ritz or Rayleigh-Ritz methods, you need to expand the solution in terms of functions which satisfy only the geometric or the essential boundary conditions of the problem. The geometric or essential, and they are the same, synonymous. The geometric boundary conditions of the problem. So those functions are required to satisfy the essential boundary conditions or geometric boundary conditions of the problem, and they should be derivable at least up to the highest derivative in the energy expressions. Now you have to understand therefore you have to understand which boundary condition is a geometric boundary condition and which is a dynamic boundary condition. For example, the string that I was just now talking about, when you fix the ends of a string, or the fixed end of a string is a geometric boundary condition, or an essential boundary condition. That is, the displacement at that point is zero. The field variable at that location is zero for all times. Whereas when we consider a sliding string boundary, then the boundary condition is a dynamic boundary condition because it involves forces. Because the end force, there is no transverse force at that end. So from this consideration, this is a dynamic boundary condition. And in Ritz methods and Rayleigh method, you need not worry about such boundary conditions. When you do this expansion and minimize the function, then automatically, because you have chosen a large number of functions, they will minimize where the correct boundary condition is satisfied. Of course, you can always choose functions which satisfy all boundary conditions, then the solution will be much more accurate. But you can do away with bare minimum, because when the problems get more complicated, the boundary conditions get more complicated, then it also becomes a little tedious to find out such functions which satisfy all boundary conditions. But you can always get away in Ritz and Rayleigh-Ritz methods. You can always get away by considering only those functions which satisfy the essential or geometric boundary conditions. Because as you know that these functions are known as admissible functions. Whereas the functions that satisfy all the boundary conditions of the problem, they are called the comparison functions. Okay, I have a point raised by Muhammad Akram, who has said, please discuss transverse vibration and rectangular membranes. I believe that Muhammad Akram, you wanted to know about transverse vibration of rectangular membranes. We have not reached that point yet in the course. When we are there, then we will discuss transverse vibration of rectangular membranes. Because membranes, as you know, are two-dimensional structures. We are currently discussing one-dimensional structures. We have just completed strings and bars, etc. So we will discuss that at a later time. But we do have this in our lectures. So thank you for your comment. I would like to know about the usefulness of these lectures in your professional or teaching activities, or if you're a student, then in your understanding of the subject and the level of the assignments, whether you're facing difficulties with the lectures or with the assignments. So please let me know through this chat box. Please write in the chat box and let us discuss such issues. Okay, I think some of you are watching this live session, and maybe some of you have already given your comments in the Excel sheet that was shared with you. I can see only 3 comments there, and I have addressed them. You can also write in the YouTube chat box. So I've just given a comment. I invite your comments or questions on the 3 weeks of lectures that you have gone through and the assignments that you have done and submitted. Okay, I think we have discussed what comments we have received. There are no further comments coming up in the chat box. Maybe you will have more comments in the forum. Please use the forum to discuss your queries or your difficulties. Please post in the forum if you have comments later on. And please do the assignments in time. That is a very important part of this course. And and these assignments are based heavily on the lectures. So please watch these lectures carefully. They have been spread out over the week. In half an hour approximately, such time duration videos. And you can you also refer, if required, to books which have been suggested. I think we are not receiving any further comments. Therefore, I think we can stop this session now. So I wish you all the best. Even though our situation is improving, but I suggest that you maintain, you be vigilant and maintain hygienic practices, and please stay away from gatherings and be healthy. So I would like to thank all our NPTEL members of IIT Kharagpur, NPTEL office of IIT Kharagpur, for making this live chat possible with you. If you have questions, queries, please use the forum. And I think we can stop here for today.